Hello and welcome at WU Vienna. My name is Sebastian Kummer. I'm the head of the Institute of Transport and Logistics, and I have the pleasure to give you some basic informations in this bridging course about transportation. The goal of this bridging course is to ensure that all students of the Master Supply Chain Management have the same basic knowledge, but also for the public to gain knowledge in transport, logistics and supply chain management. The course has three elements: this video that you currently see, the textbooks that I explained in the introduction video, and of course we have for our students here at WU Vienna discussions in the classrooms using actual challenges and cases to deepen the knowledge. This first module is about transport. I will talk first of the fundamentals of transportation, transport strategies and markets. The second part will be about the transport modes, road, rail, air and sea. The third part is about transport infrastructure. I think that not only for transport politics, but also for transportation managers and the public, it is important to have some basic knowledge about infrastructure, especially in these days where we face volatile situations. The fourth part is about sustainability. Obviously, this is becoming more and more important, and there are very interesting developments in nearly all transport modes, which I would like to share with you. The fifth part is about new development in automatization and digitalization, which obviously is changing the transport and transportation business models. So let's start with the first part, fundamentals of transportation, transport strategies and markets. What is transportation? In general, the goal is to move objects, materials or persons. So we talk about cargo transport or passenger transport from A to B, from one point to another point, without changing the characteristics. Obviously, a person should not be hurt, should not change health, should not change his character, but obviously also the goods can suffer from temperature fluctuations if you think of pharmaceuticals or of food, for example. There are two main possibilities of transportation. Transportation within a company, for example using forklifts, or much more in future robotics, or outside the company, for example using trucks, railway, airplanes or ships. In this course we will focus on transportation outside the company. The transportation within the company is obviously a very fast developing and exciting topic, but on this we will focus in another lecture. If we talk about transport, logistics and supply chains, our idea is always to look at the relevant processes. For transportation, the first process is the strategic transport planning, the strategic network planning. There very often choices of mode, which kind of transportation modes we will use, are done. If we don't use our own devices, we need to find a transportation company, a logistics service providers. Very often companies do this in a tender, where the aim of the tender is to have a framework contract. If we only have one transport and are not doing tendering, we could also do a simple request for a quote where we ask a certain number of transportation companies to give us a quote for a certain transport. If we have now the information about the prices from the transportation companies, we can assign the transport, and then sometimes already before the operative transport planning, the scheduling, the route planning will be done. Obviously, before the transport is very much underestimated, we have to do a lot of preparation. We have to think about the packaging of the goods, to check the cargo documents, which is particularly important in international transport. Maybe we have to fuel the vehicles and prepare other things. Then comes the loading of the vehicle, of the truck, of the airplane, of the ship, of the railway. Of course, there have to be a loading plan. We have to arrange the stacking of goods. The next step is the transport itself. If you think of the transport and you think of driving a car, that seems very simple for you. But if we talk about commercial cargo transports, we have a lot of legal constraints. For example, driving times. For example, regulations about the way the goods are loaded, the weight. And obviously, during the transport, especially in international transports, there has to be a lot of other activities which might be time-consuming and costly. For example, border crossings with customs procedures, or objective-related services like cooling, or tracking and tracing, which is very common in these days. That means that we can always track where the goods are. And then if the truck or the vehicle, railway, ship or airplane arrives at its destination, we have to unload the vehicle. Obviously, this is a reverse to the loading. And there has also to be a post-processing. We have to do the documentations. We have to take the goods, for example, in our warehouses. And maybe there will be also some vehicle-related post-processings like cleaning, which is particularly important for chemical trucks or wagons or oil wagons. Now I would like to talk about the evolution of transport economics and transportation. And I would like to give a short historic overview. This is because I think we can learn a lot from the history. And in times of artificial intelligence, where all the knowledge is available, I think it's very important to have an overview about these developments. Because I hope that I convince you in this short introduction that knowing the history helps us to decide developments, to evaluate developments in the present. First of all, when the transport started, natural infrastructure was used. As you know, the development of humanity, which is very closely connected to transportation, happened along the rivers. The big civilizations, as far as we know, are near the rivers, not only obviously for transportation reasons, but also because these rivers were the source for water, for agriculture, and therefore were very helpful to develop cultures. Still now, the use of natural infrastructure is very efficient. Then we see the development of cities at the trade routes. And if you look at, for example, the Silk Route, you can see also which richness this brought to the people. The trade, the international exchange of goods, but also of idea, of knowledges along these trade roads were producing wealth for the communities. If you look at the cities alongside the Silk Road, this is obvious. Already in antique times, men started to build infrastructure. Very important, obviously, is the Roman infrastructure, the Roman roads. They also built ports, obviously, which were used very, very long time after the Roman Empire collapsed during the Middle Age times, and are still until now visible and from the routing being used, because obviously at these roads there was the development also of the different cities. But not only the Romans, already before the Greek were using infrastructure to support the transport. For example, the Greeks were building channels at the Kalkidi, the Three Fingers in the north of Greece. Cleopatra tried to connect the Red Sea and the Mediterranean, the Nile. And so there were a lot of infrastructure projects in antique times. What is also very important if we look at transportation is that very often transport is using sophisticated transport organizations or networks. If you look at transportation companies, if you look at the way modern logistics service providers work, if you look at the way modern airlines work, shipping companies, railway companies, trucking companies even, they all operate sophisticated transport networks. And these networks already occurred in history. For example, the Chinese had a network of stations where the horses could be changed and the couriers could sleep and could eat around every 30 kilometers. And in this way, informations and orders of the Emperor of China could be transported in a very quick way. Basic innovations were very important for the transportation. For example, the steam engine is obviously important for the industrial production, where the energy does not come anymore from men or from horses, but from the steam engine. But for modern transportation, this was the biggest invention. Especially with the combination of iron or steel, the railway could be developed. We could build railway tracks, we could build railway wagons and locomotives, which were driven by steam engines at the beginning of the railway. And with the development of the railway, continents could be developed. Without railway, no development of the United States, but also no development within Europe, because within a short time, a quite sophisticated railway network all over Europe was developed in a very fast time. And if we talk now about the speed of railway, if we talk about decades that we need 20, 30 years to develop new railway lines, at the time when the railway was invented, in these 20, 30 years, nearly all the most important railway lines in Austria, Germany, and all over Europe were built. Although at the end of the 19th century, the possibilities were not like we have now, they built in a much faster speed. Obviously, a great invention was the Otto engine, which was driving the development of the cars although the first cars, as you probably know, were battery electric. But as this technology was very limited, and when the Otto engine was developed and used in the cars, the success story of the cars and later trucks arrived. Information and communication technologies played a very important role. Who had the faster information had a superior knowledge. Already in the times of the German Hanse, which was a great network, we have had the before sophisticated transport and organization network. It was a network for transport. The Hanse was very important for the ships, but also of customs, of military activities and informations. And who had the faster information could therefore buy already faster things or sell, and therefore have a financial advantage. For example, arrival of ships was very important. There were light signals given to give the information that ships, for example, the tea liners, when the tea was exported from China, were coming. The first tea was the best and most expensive. There were signals given at the rivers in Germany, at the Weser, and also at the Elbe River. The information was given with light signals and flags to announce which ships were coming, so the deloading and loading could be prepared. And obviously now the information and communication technologies are very important. Very much underestimated is the impact of ideologies and the availability of knowledge in the history, but also in the present. I think that some of the developments that we see now in transportation are very much driven by ideologies, and that is not good. And if you look back at the time of the discovery and the explorers, for example, of Columbus, for sure he tried to ignore some of the ideologies, obviously, of the Catholic Church. He did some research. For example, he went to England. Some say that he was reading there or had access to knowledge about travels to America, maybe from Vikings. As you know, the Vikings were before in America, or other reports from fishermen. Anyway, what is very interesting is not that he falsified the books about his traveling, not to show to the crew how far they were towards the west, but also what is very interesting, that after he was discovering the Caribbean islands, Bahamas or Hispaniola, he, because if he would think that these were the islands that were in front of India, one would have thought that he would go further westwards to discover India and to find the final way. But what he did is he did not even return to east, but what he did is he went first north, and then, using the west wind situation in the North Atlantic, traveled back home to Europe. And that is very interesting, because, and most probably he had informations about the trade winds on the Atlantic Ocean. Obviously in the south there could be some, we could have had some informations from Canary Islands, but it's very strange that he went from the Caribbean to the north exactly the right way, where you have to sail. So from my point of view, also not only in history but also now, it's important to at least reflect the ideologies and try to have a rational approach using the available knowledge. We always think that the developments in transport in these days are very quick, and that this is very challenging. But if you look at the history, there were also very big and fast changes. When I was teaching in St. Petersburg, I found this very beautiful picture of Camille Pissarro. You see here, this is a Boulevard Montmartre in Paris, obviously beautiful. And you see it's full of carriages with horses. So, and this is in 1897, so at the end of the 19th century. And next slide shows Paris in 1911. So only 14 years later, Albert Maquet, also a French impressionist, chose the Place de la Trinité at Paris also. And what you see here is, yes, there are still some horses there and carriages, but you see already here the tram going and the electrification is coming, and the mobility is changing tremendously from the horses towards electric driven vehicles and later cars and buses. And this within a very short time. We will come to that later also if we look at developments in other areas. Today's transport management challenges are obviously great. We have global supply chains with long lead times. We have a rising and shifting customer expectations, so it's really very difficult to reach the customer expectation. We have a high volatility in prices, in transport prices, but also obviously in the costs of the transport, raw oil and other elements. Beside that, not that the volatility is high, but it's also unprecedented. So we don't know really, sometimes it's high, sometimes less. And what is obviously in these days, since the COVID-19 crisis, we live in a time where the risk really increases because of the wars, because of energy crisis, because of many reasons. And this, of course, makes the transport management very challenging. And of course, we have sustainability needs, which are a challenge, but obviously also the volatility. And every challenge is also a chance. And regarding the sustainability, I see a lot of challenges if it's done in an ideologic way, but a lot of chances if we use the opportunities that are there, for example, for battery electric vehicles. We will show in the last part that from my point of view, if you manage it right, if you find the right applications, already now battery electric trucks are economically feasible. And another big challenge is the changes of the technology and the rapid change of the technology. Battery electric vehicles, artificial intelligence, robotics, autonomous driving are already changing transport and the transport business models, but will in future change them much more. And the companies have to be prepared, but also you as students have to be prepared, the managers have to be prepared, and obviously also scientists and professors have to think what will be the consequences of this. And from all that I know is that we will see in the next 10 to 20 years tremendous changes in our field. Now we come to some basics. I would like to show you my idea of the economic transport map. And I think it's particularly important to have an overview about the different transport systems. Very often we look only at the transport from a very narrow way, for example, only from the company way. But as scientists, but obviously as managers, it's important to see the big picture. Obviously, all the transport is in a space or in an area. We are doing this transport in natural environments, which is very important because obviously we'd like to not harm nature. We are in a cultural environment, which is obviously important for passenger transport, but also for cargo transport. And if we do business, obviously we are working in a legal framework that we have to follow. That is obviously different in different countries and different transport modes, for example, also. So there's a lot of different legal aspects, and obviously a lot of more that builds this framework. On the other hand, we have the individual person. Obviously, for the passenger transport, that's important. Does he feel comfortable? What are these needs? Do we meet with our transport offers the need of these individual persons? And very often in modern transport, especially if we talk about environmental or green ideas, they want to force individuals in some areas, which I think it can only be the ultima ratio. And before, we should try to use incentives to incentivize individuals to behave in a good way. But not only for passenger transports, the individual person is important. Obviously, if we talk about cargo transport, behind, at least until now, the decisions about the transport are individuals. But these individuals not act like in the textbook, always in a rational manner, but also they can have their prejudices, they can have, maybe they have better information for some areas and therefore have individual decisions being taken. Then we have the institutions. This is what we management science in our business and administration looking at. We think that we can look at the processes in the institutions. We can think what is the organization of the institutions, what is the legal framework for the institutions, what are contracts they are doing, and obviously what are the transactions that are done between institutions, but also of course between the institutions and the individuals, because the individual is not only a customer but also as I said, an employee and therefore or a stakeholder. So there are many roles for individuals. So the institutions has to deal with the individuals on the one hand side and obviously also with other institutions on the other hand. Then there's the market. We have obviously some market failures in the transport, but at the sum, from my point of view, in many areas, the market and the incentives of the market were giving a huge benefit for the development of transportation. If you look at the airline industry, at the air transport, as well for passenger and cargos, with the opening of the markets, the development really exploded. It was able, the people were able to travel airplanes long distances, which before that was only something that was available for wealthy people. But also we have seen the huge effect of the opening of the markets in the truck sector, where the competition grows. Before that, it was a very regulated market. In the maritime shipping, it was always more or less a market. There are also, from my point of view, positive impacts of the market opening for the railway, although a lot of people would ignore that. But if you look, for example, at Italy, where the opening for the long-distance railway, passenger railway, for Italo and the competition between Italo, which is a private company, and the Trenitalia, which is the state-owned company, that lead to a competition that led to lower prices and very good service and very high reliability also. So really very good and important effects. I personally think also in Austria we have only very small competition in the passenger railway on we call it the Westbahn, and the company, which is a private company that is a competitor, calls itself also Westbahn, which is the railway from Vienna, Linz to Salzburg, and then obviously to Munich. It had a very positive effect. In the cargo, the competition is much stronger. We have in Austria, there's only the single wagons are 100% or nearly 100% done by ÖBB. But if you look at full trains, I saw the new statistics. In Austria, nearly 50% of this market is done already by private companies, and the competition between the Rail Cargo Austria, which is our national carrier, and the private companies is quite heavy. Same in Germany, and I think the market opening had a very positive effect. Some see it a bit more different, but in the cargo, mostly it was positive. I think if we would have stayed with the protected monopolists in the railway sector, this is a kind of romantic idea that this would have been a better option. This is the economic map. You see here, if we talk about business models, we have to take into consideration all these aspects. If we talk about transport politics, as I did now, we have to take into consideration all these aspects. And therefore, I think for you as students and for you as managers or as customers, it's always important to have in mind these different layers or systems of the transport economic map. Let's continue with the basics. Modal split shows the usage of the different means of transport, and the most common measures are the kilometer times the tons, or kilometers times passengers, which is in the passenger transport. The way to measure the modal split, kilometer times tons, is in the cargo transportation. One could also only look at the tons or only look at the transported passengers. Other measures could be dense of transport. And guess which of the different means of transportation is used the most in freight business? And I always say the right answer is it depends. The question is on which it depends. We will see later. Here you see the development of the transport sector in Europe. We will see similar development in other countries, but also different developments. You see here, this is billion ton kilometer. In 1970, 1,407. The road transport 35%, ocean shipping 34%, pipelines 5%, inland waterways 7%, and railway in Europe 20%. You see what happened. The transport between 1970 and 2000, so in 30 years, more than doubled. From 1,407 went up to 3,078. Nearly all transport modes were growing. The only mode where the ton kilometers were shrinking, also nominally, was the railway. And therefore, the market share, the modal split from railway, was diminished from 20% to 8%. Inland waterways also suffered in terms of market share. They fall down from 7% to 4%. The number of ton kilometers increased a bit. Pipelines suffered also in terms of market share, but quite huge increase. And the only two transport modes that were dramatically increasing was the road, which could increase the market share from 35% to 44%, and the ocean shipping. This is only intra-EU, so within the European Union, but internationally, obviously, it grows also tremendously. You see here the growth is 3.5% per year for the road, 3.4% for the ocean shipping, 1% for pipelines, 0.7% for inland waterways, and the railway was shrinking with 0.4% every year, growth of ton kilometers. Within the European Union, 2.6%. If we go now further, in 2013, you see that the development is going further. Road, which before had a market share of 44%, is now 52% in 2013. Air more or less stays the same. Inland waterways stay the same. The railway in this statistic seems to recover, but you have to take into consideration that in between 2000 and 2013, there was the enlargement of the European Union towards the east, and the former socialist country had a far higher modal split of railway. For the same reason, the modal split of the maritime shipping within the European Union shrinked. The shift from rail to road slowed a bit down from 2013 to 2018. You see here, road still gains a bit of market share, railway loses 0.2%, but not so much. Maritime shipping inside the EU is growing, and inland waterways are suffering a lot, especially also in Austria. Air stays the same. If we then look at the development after the pandemic in 2024, I have to say I make this statistic because, as you see on the next slide, the EU only publishes now maritime shipping as a whole, and that is not comparable to the other statistics. We see that the shift from rail and inland waterways to road is speeding up after the pandemic. Railway is losing market share, inland waterways is losing market share, and road significantly gains. The maritime shipping, as I said, I estimated that one reason why it's a bit lower is because the international lines are now operating more directly towards also Eastern European countries and also to the Scandinavian countries, and therefore the feeder shipping within the European Union is slowing down. This is what was published by Eurostat. Statistic maritime is all maritime, so international shipping and inner EU shipping. You see that it slightly goes down because of the effect that I explained before. Road is gaining, railway is shrinking, and you see that inland waterways and also air transport inside the European Union are very, very low. Obviously, the modal split depends very much on the distance. You can imagine that if you are traveling, if you travel short distances, maybe even walking and going by bicycle will be the best. If you travel a bit longer, maybe then you would use the car or public transportation. And then there is a distance where there is a severe competition between a railway and cars, for example. It depends very much on the railway connection. So if we're connecting, for example, if you are traveling on a high-speed train, then very often the railway has advantages not only in cost but also in traveling time. But if you're traveling from a more remote area to a remote area, maybe the car will be more convenience, definitely, and more and faster for the cost. That's always a question how you calculate it. If you travel 2,000 kilometers, the traveling time of the plane will be maybe 2.5 to 3 hours, or obviously you have some time. The complex traveling time would be longer because you have to be before at the airport, you have some operations at the airport, but time saving is a lot. There are some ideas to have European night trains in the passenger transport, but it turns out to be very, very difficult from the economic point of view. From my point of view, fast trains up to maybe 800, 1,000 kilometers. That's a good distance where if you're traveling fast, maybe you can reach 5 hours or 6 hours of traveling time, and then it's more or less acceptable. And for the cargo, the distance plays also a very important role. Obviously, for smaller distances, normally the trucks have a huge advantage, because if you have a railway transport, very often you have to load and unload the goods. There's a long research tradition on investigating the impact of distance on mode choice in freight transport. Here I show you a graph from Borut Czonyok, Metka Takavic, and Marko Jaksic from 2019. They investigate the influence of the distance on the competition of unimodal road and intermodal railroad. And you see here a corridor, and the average here using the Euclidean distances was 640 kilometers. Below 640 kilometers, the trucks cost less. Instead, over 640 kilometers, intermodal railroad is more cost efficient. Obviously, there's a corridor you see here, and these 600 kilometers are only one calculation. They did a lot of simulations here. So, in fact, most of the studies say between 500 and maybe 700 kilometers. But also here, it depends very much how much border crossings I have, what are other influencing factors. But unfortunately, in Europe, we have still some truck transports for long distances. This is due to the fact that the railway sometimes is, even on the long distances, not so sufficient. If we then talk of intercontinental transport, although for example, Eurasian land bridge, the new Silk Road, is very successful on the railway and growing very fast, but most of the percentage of the transported goods from Asia, from China to Europe, but also obviously to US, is transported by container ships. To US, obviously, there's no possibility to go by train, but obviously there's a chance to go by plane. But air cargo is much more expensive. We will come to that. Maybe 10 times more expensive than container shipping. And then the effects of transported goods. It has to do, obviously, if you have very valuable goods, you are interested to ship them faster because of the capital bounded in the transport. So there we have a high percentage of air cargo. So, for example, I don't know, jewelry or computer chips or expensive spare parts. They are all, not all, but very often transported by air. Instead, if we have very, very low-cost goods, for example, trash, then obviously the slow transport modes like the inland waterways play an important role. Also, if we have mass transportation, for example, iron ore for the steel industry, or if we have oil or chemicals, there the inland waterways are very, very effective and very competitive. Also, some construction materials, for example, if you transport sand, the speed is not so important. Let's come to the types of transport and transport processes, chain of transport means. We have the single-step transport. Here, a direct could be an option, means we directly load into a truck goods and drive it from one door, we say one company, to another company or to the customer. It could be also in the train, full trains. We have one full train driving from one company to another, or direct shipping also from one port to another port. If we talk about part load, that means that we have continuous transport. The goods are not loaded and deloaded during the transport or transshipped, but for example, one truck will go from one customer and deload the goods, go to the second customer, and then to a customer. The same could be also for ships and also for railway. It's not so common, but could be done also in a way where we split then the wagons. That could be a kind of single step railway part load. If the goods are loaded or deloaded, we talk about multi-step transportation. This can be done only using one mode, then we call it unimodal, or we could use different modes, for example, a truck and a railway, or a railway and a ship. Then we call this multimodal. In the unimodal world, we could load and deload the cargo from the vehicle directly. For example, we could drive from a company to a transshipment point, take out the goods out of a truck, for example, and then load them to smaller trucks. Or we could use a railway, bring it to a station, take out the goods and load it to another railway wagon. If we use a unit, for example, swap bodies, then this is only a transition of a load unit. It could be as follows. We drive with the truck with swap bodies to a parking space. There we stop, we take off the swap bodies, another truck comes and then takes the swap bodies and brings it to the final destination. It could also be used from retailing companies. They use a lot of swap bodies. A swap body looks like a container with legs. The legs can be folded if the container is on the truck. This should be the truck. And when the truck arrives at the destination, the legs are defolded and the swap body can stand alone. Very interesting and promising if we talk about shift, for example, from road to railway, the multimodal transportation. And the multimodal transportation means we have more than one mode. Obviously, we need multimodal transportation very often for railway and for ships and also for air cargo. Why? Because not so many customers have their own airport and not so many suppliers have their own airport, and even if they have, it would not make sense. And the same is for the railway. There sometimes we have, for example, we could have railway transports from a steel producer to the automotive industry, also discontinuously bulk cargo or break bulk cargo. But more interesting is what we call the combined transport. That means we use a standard unit. There are different ways. Piggyback traffic means that a truck drives to a station and then drives on a railway wagon and then will be transported for a longer time towards the destination. You see on this graph on the second line a combined transport with transport vehicles as load units. Above the trucks that are driving on a ship, that would be called fishy baggy, and down you see the trucks on the railway wagons and then driving as a train. That would be piggyback transport. In practice, fishy-back traffic would be called roll-on, roll-off, as the trucks roll on a ferry boat and roll off the ferry boat. This can also be done with railway. We have, for example, on the Caspian Sea, if we go from Kazakhstan to Azerbaijan, the railway wagons will roll on a railway ferry boat, then cross the Caspian Sea to Azerbaijan, and then roll off the ferry boat and then drive with a locomotive further on. Swim in, swim out is a very special action done, for example, in Mississippi, where there's shallow waters. They use barges. The barges swim in a bigger ship. When all barges are in, the ship is closed, the water gets out, and then the transport can be done. Most important for combined transport is the transport using non-autonomous load units, containers, swap bodies, or also trailers. The most important combined transport is the transport using autonomous load units. You see here on the top the containers or swap bodies are loaded on the ships, on the railway with cranes. There could be also other modes done and then transported, and at the destination again deloaded from the ship or from the railway with a crane and then transported to the customer. If we use the trailers from the trucks and not the whole truck, we call that in Germany unaccompanied combined transport with non-autonomous load units. The trailers are loaded with cranes to the railway. On the ships we don't use cranes, but very often small special trucks are used. And shipment points are terminals where goods are loaded. The functions are break or bundle the transport, sorting, or some additional services, for example, warehousing. And we have different kinds of transshipment points. The reason could be technical. For example, as I said, between China and US, you cannot use the railway and you cannot use the truck. So you have to have a transshipment point, a port. You bring the goods with the railway to the port or with the truck to the port, then ship it with the ship. And then in the US, if it goes there, you bring it then to the final destination. Legal aspects that you have a transshipment point because you have to do maybe some inspections for legal reasons, or sometimes also, for example, trucks are not allowed if they go from outside. They have to have the special permissions, then they can drive within the European Union, otherwise they cannot do. It could have also cost reasons, as I said before, to bundle in a shipment point. That is what a groupage forwarder, for example, does. There are different transshipment points according to the dominant transport modes. Ports, I already mentioned, airports, obviously, then stations for the railway. Of course, also we have connection with other transport modes, or we try to have more than one mode within transshipment points. Then we call them intermodal transshipment points or logistics centers. We have in Vienna, we are very proud that we have within the area in the east of Vienna, the airport, the inland waterway port. Obviously, we have a railway terminal in the port also, and the trucks are there. So we have 4 modes there. They call it 4-modal logistics center. Let's come to production types, direct transport, tours, transport networks and systems. It sounds to be a bit of academic categorization, but you will see it's very useful. Direct transport means that it's a door-to-door transport. The passenger takes a car. Non-stop flights could also be a direct transport if you have the point of view only from the airline. In the goods sector, we also have that. We have full truckloads, for example, truck is loaded at one company and brought to the customer and unloaded there. We have sometimes express services where a courier comes to a company, picks up the goods or documents and directly drives it somewhere else. And here this is a direct transport from one point to another point. Then we have the production type tour. For example, typical round trip. That would be, we have a depot where the tour starts. We have different customers or even pickup points. So we deload at the customers or we pick up at these points and then go to the next one, and then return to the depot. Or we have we call this milk run. It comes from the milk cans that are carried. We start here at one customer, we take something there, here, and then return. It's something that the automotive industry uses. Tours we have in buses or railways operate very often in tours. We have flights with stops. The airlines don't like them anymore so much. For example, we had a flight from Vienna, Leipzig, and then Dresden, and then returning to Vienna, so a triangle flight. Of course, a shared taxi or a bus drives a certain route, could be in the passenger. At the milk run I showed you before, express services could use that they have special routes that they're driving, or the less than truckload. We have a full truck, we start with it, we stop at the first customer, we unload something, we go to the next customer, then next and next and next. And then the most complex is the transport networks or systems. In the passenger transport, we have a bus and railway with hubs, or line carrier. Hub is always a point where many lines or routes are bundled, and then the passenger is changing the railway. For example, in the railway, we have regional railway lines that lead to Vienna. From Vienna, you will take the fast train towards, for example, Salzburg or something like that. That would be a classical network approach where we have the station as a hub. All the big airline network carriers are operating with hubs. For example, Turkish Airlines, they carry the passengers from Europe to Istanbul with short or middle range flights. From Istanbul, you take a long way flight and then maybe even another flight. Or via Frankfurt or Vienna, Amsterdam for KLM, Paris for Air France, and so there's a lot of examples like that. Or the Arabic carriers, obviously, also they carry the passengers, fly the passengers to the Gulf region, then you change the flight to the next destination, and this is a typical network or system approach. For the goods, very important, less than truckload or groupage or freight forward. This is a typical groupage freight system. We see here routes or round-trip routes that are picking up the goods, bring it to a depot. Here we don't have only two depots, but this is only a schematical description. We bring them, we call that line haul, towards the destination depot, and then on a route here they will be delivered to the customer. You can imagine that this is quite a complex activity. You have to organize this, we have to organize the transshipment, you have to organize the line haul, the transshipment here, and then so it's quite a challenge. We have same for parcel services. They operate the same. The depots are a bit different in groupage, very often still manual. In parcel services, automated hubs where the parcel is sorted automatically. Mainly, actually, they are also, of course, manually done. Yeah, postal services or express services that are operating this way. I would like to come now to the automotive industry, because the automotive industry says, we have here our automotive plant or here, and we say we don't need here these groupage services to collect the goods and to bring it to maybe Munich and then on a tour our BMW plant, because we have so many suppliers in one area that we could collect them here. They call it regional forwarders. So they would, for example, of Germany, North Rhine-Westphalia, coal area regional forwarder would collect all the goods and then bring it directly to the plant of BMW in Munich. So one transshipment point would be avoided, and therefore the regional forwarder design is more efficient than the groupage freight design. And then they say, yeah, maybe it's even not so inefficient to use a transshipment point here. Why don't we do a milk run? So we use 5, 6 medium-sized suppliers. One truck is collecting these and then bringing it directly to the plant. Or if you have very big suppliers, obviously, or big items, for example, for seats or something, maybe they use in the automotive industry direct transport. And so this was a development from the automotive industry. They're using everything. So maybe they have item or come from regions that are not so good connected, then maybe they would use traditional groupage freight, they would use regional forwarders, milk runs, and also direct transport. So in the automotive industry, you could maybe find at one plant all of these transport activities. Let's come to the end of the basics. Transport cost market analysis is a starting point of the transport strategy, and I would like to show you how high the volatility is, not only now, because most probably you know that in 2026, when this video is recorded, the volatility is very high, but we had high volatility in former times. Not so much within a short range. This is a Bloomberg commodity index. It's an index. You see here how it was 2070. Weighted grains, energy, livestock, softs, industrial metals, and precious metals. So quite a mix. There was growth all until in 2008 the financial crisis, Lehman Brothers, you remember, hit and then fall down tremendously. You see here from 2040 to something like 100, so really tremendous fall. It recovered from 2009 to 2011, and then something very strange happened. There was the estimation that we will still have this big growth in the upcoming years, but from 2011 to 2020 we had an oversupply, energy, precious metals, industry metals, maybe also even grains. So there was an oversupply and only very slow world economic growth, and this leads to really a huge decline in this index. And for example, raw materials were going down. And then what happens, obviously, very often there was not so much invested into mines. Nobody wanted to invest anymore. And then you see here, COVID-19 came, the prices went down tremendously. The oil price, for example, there were sometimes negative oil prices. So if you would have the financial resources I wanted to do, but of course I could not do, because you would have to buy a whole tanker, the whole of an old tanker, and so you get the oil for a negative price, but of course you have to pay the charter, the rentage, the lease for the tanker. It was a huge, they make profits you cannot imagine. It was only very, very short time that there were negative oil prices. Then everybody saw, yeah, life will go on. Next, it falls down, not like in the 2008 crisis, because it was not so high in percentage, also very much. And then we have from 2021, after the COVID, you remember there was a lot of demand underestimated, and the prices went up, so we had the information there. And since then, quite high volatility on the long way, but also in the short way. And obviously here driven by the wars. And here you see the high volatility in the oil prices, which are for the transport sector obviously very important. We see here the first oil crisis in the 70s and the deep fall and rise after the 2008 and the COVID-19 crisis. This last increase here in the oil price you see before it was going down was done by the Iran war. Then it went down a bit. Now, as I'm recording this video, we still have again the fighting going on, so it went up again. So we see a huge inflation in the oil price, and this obviously is reflected also in diesel, benzene, and kerosene, so jet fuel. And the problem is obviously that the margins in the transportation sector are very low. This is a substantial cost percentage. You have to try to take that into the contract. So we use in the transport contracts, especially in trucking, very often diesel floaters, but also in parcel services or groupage services, diesel floaters that are reflecting these price fluctuations. From my point of view, in both directions, up and down must be, because they are constructed in a way like this. But obviously, forecasting transportation costs is very important to have an idea, but very difficult. And I like very much this citation from Johann Wolfgang Goethe. We love to look in the future because we are eager to influence the uncertainty which is moving from one direction to another, with our silent wishes in the direction we want the future to happen. One always have to be careful that you don't make your wishes the forecast. For example, if you are a fan of a football team or of a nation, you wish that they will, and then you think also they will. Yeah, but if a small club from your hometown plays against the Real Madrid, maybe the probability is very low in reality. This is really something that we have to be careful. So don't try, be always careful. If you see, if everybody panics and sells the oil because they think the world crash or something like that, then you have to be rational and have to say, we will still need oil, maybe not so much, but if I can buy oil on a negative price, I will do that, because the prices most probably will go up. And if they go down and stay zero, maybe that's the end of a world, at least in an economic way that we are working. So I like this very much. Obviously, that already Goethe know that there's this movement. And let's look at the cost. In the 70s, we had a linear cost, and it would transport longer distances, especially in international transport, would be quite expensive. And what happened, the number of goods transported grow tremendously in the 70s, 80s, 90s. But also what happened is we were able to reduce the cost, especially in the international transport, because the ships were getting a bit bigger, the planes were getting bigger, we were getting much more efficient. And that led to the fact that the transport cost, it's not empirical here, but only to discuss it, they were flatter and the distance was getting less important. For example, if you have a transport from Asia to Europe, most probably will be cheaper than from many parts of Africa, although the distance from China is longer than from Africa, because the transport from China and towards China is much more efficient. We use bigger ships, ports are more efficient, and so on. So what happened is, and I wrote until recently, we have seen also from, let's say, 2000 to 2010, in most of the areas, costs going down. In the US already, I think it moved 2005 or something like that, that were not going more up. Of course, we talk here about real costs, not the inflation you have to take into consideration. Obviously, the costs are going nominally, they are also fluctuating, but more or less nominally going up. But for example, if you look at container costs for container shipments, you have even on the nominal basis the same costs now that you would have 30 years ago. It's incredible. It's an older slide. I did that maybe 12, 15 years ago. And there we said in future we will see this cost increase due to the fact that we will have CO2 cost increase in the transport. As you probably know, international ships and flights don't pay any tax on the fuel. We see that now that on the road transport, for example, it's getting more expensive. Yeah, railway is another story. So our estimation was always in the last years that we will see a rise in the transport costs, and especially here in the distance, because if the fuel costs are rising, the energy costs are rising, then here the distance plays again a role. Here the cost for the short distance is very high because we have the loading, unloading, transshipment or something. Then we have some costs that are not related to the distance. One has to go now to every area. We'll do that in the next video, but more or less we see that there's still in the carriers, in the railway, in the truck, in the shipping lines and air also huge competition in the transportation industry, and that is why it keeps the cost more or less low. But due to the structural changes in the world trade, I think that we already see now a change, that the shipping companies try to keep the container costs high. If I would be a logistics manager and if we consulting logistics companies and transportation companies, I would say that you have to be prepared for higher prices. And said that, you can imagine how the fuel prices went up when the Iran war started. So if you would or if you are prepared for these kind of fluctuations, that's always important. So thank you very much. I hope I could give you some ideas about the transport. We will go on in the next video in the transport modes: road, rail, air and sea. You will learn a lot more about these. If you like the video and if you're still there, I hope you are. Please give me a thumb. If you want to see more videos about not only the basics of transport, but also I have very interesting videos about AI, resilience, battery electric vehicles, many of them in English, some unfortunately in German. You can do abonnement of my channel, ring the bell. Obviously, it's without of cost. Thank you very much for listening and hope to see you in the lecture room or somewhere else.